Our lesson objective is I can determine the reference angle for a given angle. So before we do determine the remaining points on the unit circle, it's necessary to discuss some important terminology, which is specifically a reference angle. So a reference angle, so for an angle theta that's in standard form, a reference angle is the positive acute angle formed by the terminal side in the x-axis. So it's really important here is that you get comfortable, well, this part will be fine, right? Like this is going to be your initial side, but then the tricky part will just be, okay, this is the terminal side. So that's the part you have to just pay most attention to. So we're going to find the reference angles for 150 degrees and 315 degrees. So for 150 degrees, this is our initial side. I'm going to go ahead and draw my angle in standard form. So this is 150 degrees here. And the way this works is you have to use the fact that this is 180 degrees. So this angle here will be 180 minus 150, which is 30 degrees. Now, if I chose to look now at the 315 degrees, this will be my initial side. This will be my terminal side. So this here is 315 degrees. If I was interested in this part here, this, again, you have to highlight the terminal side. This is the terminal side. This is the angle formed by the side of the terminal side and the x-axis. So we're interested in what this angle is. This here is our reference angle. I think it's yeah. So we're going to do 360 degrees minus 315 degrees. And we have 45 degrees. Now we have to do negative 240. And then we have 1 in radians. So the way this works is when you're going clockwise this way, this will be 90 degrees. This is 180 degrees. This is 270 degrees. This is 360 degrees. And when we're going in reverse, sorry, I was trying to decide if I should include the radians here, but I'm going to just wait till the next part. So if we're going in reverse, we're going to do negative 90 degrees, negative 180 degrees, negative 270 degrees, and then negative 360 degrees. And that's if you go this way. So we're going to use this approach. So we're going to draw our initial side, and then we're going to draw our angle in standard form. So this is going to be negative 240 degrees. So we need to figure out now what this angle is here. Well, we know that this whole thing around is negative 240 degrees. And what I'm saying is we need the answer to be positive, but we can think about it like, okay, what if we do minus 180 degrees? And as long as we remember, okay, this has to be positive at the end, it'll be fine because this will be negative 60 degrees. And we just say, okay, it has to be positive though. No matter what, reference angles are positive. So we can say it's 60 degrees. That's a way you can also think about it when it's negatives if you have to deal with that, because I think that can be a little tricky. So then when we do the 5 pi over 3, the way this works is 90 degrees is the same as pi over 2. I shouldn't even draw a slash. It's just they're equal. 90 degrees equals pi over 2 radians. And I'm going to do it actually in a different color. 90 degrees is pi over 2 radians. 180 degrees is pi. 270 degrees is 3 pi over 2. And then 2 pi is 360 degrees. So I'm going to go ahead. And the way I like to think about this is I like to actually write this. I'm going to keep the degrees over here. I like to think about this actually as 3 pi over 3. And I really only focus usually on between 3 pi over 3. And then I say, okay, this is going to be 6 pi over 3. So what I recommend is that we make common denominators between our angle in standard form and then all of our quadrants, because it'll be easier to determine where this value will be in our coordinate plane. So this is 3. We have 2 and 2 as our denominators, though. So what I'm going to do is make all of these have common denominator 6. So we have our unit circle value, so I'm going to get rid of everything else we don't need. So I'm going to go ahead now and draw this angle in standard form. So it's going to live in this quadrant. So this is going to be 10 pi over 6, which is the same as 5 pi over 3. And then it just makes this much easier. We now can do 12 pi over 6 minus 10 pi over 6. And that's going to be 2 pi over 6, which will be pi over 3. So here we have 7 pi over 6. So what I'm going to do is first write the values of my unit circle, or the measures of each quadrant, I mean. And we want everything to have a common denominator, and it looks like the easiest one would be 6 here. So we see here that 3 pi over 2 will be 9 pi over 6. We multiply the numerator and denominator by 3. Pi will be 6 over 6 times pi. Pi over 2 will be 3 pi over 6, and then 2 pi will be 12 pi over 6. So we can get rid of the non-common denominator. And now we go ahead and write this in standard form. This is our initial side. Then this will be our terminal side. And if I was interested in figuring out what this value is, we could do 7 pi over 6 minus 6 pi over 6, which is just pi over 6. So the answer to this one is pi over 6. Now we're going to do negative 5 pi over 4 using the same approach. So I first write my unit circle values, and I want them all to have a common denominator as my angle I'm interested in finding the reference angle for. So that's 4. So we're going to convert all of these to have a denominator of 4. And then again, just get rid of the stuff we don't need. All right, now we can go ahead and find the reference angle. So we have negative 5 pi over 4. So I made a mistake right here. This has to be negative 2 pi over 4. Oh, yep, negative 2 pi over 4. So we're going to draw our reference angle. It's negative 5 pi over 4, so it's going to be in this quadrant. So we could do negative 5 pi over 4 minus negative 4 pi over 4. But the problem is that we're going to get a value of we're going to get negative pi over 4. So you just have to remember the reference angle has to be positive. So you're going to say instead pi over 4 for an answer. After this lesson, you can determine reference angles for given angles in standard form.